Hello viewers, today 29th of March the year 2024 we are part 2 of the topic further logarithms. Today we are going to tackle 8 questions on logarithms. Note that these are past KCSE questions for the previous years. Subscribe to find any working from Google search. When you search the questions directly, this will only apply for my subscribers of only the made familiar topics or questions in my channel. But before we proceed to the questions, let us see summaries on the topic further logarithm that I made to make the topic so easier. Let us see some of the summaries. So this is the made familiar book. This is the made familiar book. This is the book I have been talking about, and the questions in the book. These are the question. The question is logarithm notations. These are the questions. These are the questions on logarithm notation. And before we proceed, we have our summary. But note that I copied the questions on bigger paper so that they can be seen so clearly. So these are the questions that I copied from the made familiar. Note that these are past KCSE questions as labeled. These are the questions. Now, if we go back to our summaries, these are first page of our summary. This is the first page of our summary. As you can see, this is the first page of our summary. And this is the second page of our summary. And this is the third page of our summary. We're turning to the fourth page of our summary. This is the fourth page of our summary. And this is the fifth page. This is the fifth page of our summary. And lastly, this is the sixth page. This is the sixth page of our summary. So let us remind ourselves. We are going to remind ourselves on some of the key concepts that one should know before diving to the questions. Now, for example, if we are told change 1 and 2 into logarithm form in log base 10, see, we say that to change 1 into log base 10, 1 is equal to log base 10, or 1 is equal to log as you can see, the log is indicated by base 10, but it can as well be written 1 is equal to log. If you see the log is not indicated, know that it is base 10. So to change that into log base 10, 1 is equal to log base 10, or 1 is the same. That is the same. Now, when 1 becomes the power here, because 1 is equal to log base 10 is equivalent to 1 is equal to log base 10. But if 1 becomes the power in this, can also be written as log base 10 is equal to 1. Now if this one becomes the power, this will give us log 10 base 1, this one. So this, if it becomes the power 10 comes there, then this will be equivalent to log 10 base 10 is equivalent to 1. Log 10 base 10 is equivalent to 1. And for the sake of 2, we say 2 is equal to log base 10, or log base 10 is equal to 2. Remember here there is 10. When 2 becomes the power, this will be log 10 power 2. This will give us 200, because 10 power 2 is 100. Therefore 2 is equivalent to log of 100 base 10. Remember, you should always know that 1 is equivalent to log of 10 base 10, and 2 is the same as log of 100 base 10, and 3 is equivalent to log of 1000 base 10, and 4 is equivalent to log of 10,000 base 10. As you have seen from our calculation, that's how we can regenerate our logs from whole numbers. But for the sake, if the log is not in base 10, we say that changing 1 and 2 into logarithm form in a non-base 10 logarithm, e.g. log base 2. For example, if we are given log base 2, let's say 1, to change 1 into log base 2, say 1 is equivalent to log base 2. Therefore, this is equivalent to, this can also be written as log 2 is equal to 1. Now, when 1 becomes the power to 2, this will give us log 2 power 1. Remember, 1 will be the number in the log here. Therefore, what we call sometimes exponent, then this becomes log of 2 base 2, because the exponent, by if 2 is power 2, 2 will lie here. Therefore, for the sake of 2, we say 2 is equivalent to log base 2. this can also be written as log base 2 is equal to 2. Now when 2 becomes the power, here, this will be log base 2 power 2. See that 2 power 2 is 4. Our exponent will be, this will be log 4 base 2. Now, and this is how we can generate our logs. This is how we can generate our logs. This is how we can generate our logs. Now let us now work on questions. We are going to start on now question number 25. Question number 25. Question number 25. This is to solve for x. States that question number 25 states that solve for x in log 7x minus 3 plus 2 log 5 is equal to 2 log plus log 3x plus 3 4 marks. This was a KCSE question 2019, paper 2, number 15. So for question number 25, we say solution. Now first we are going to, because you can see that we have 2 is a, this is a whole number, and we have to apply the, first we are going to apply the power rule in 2 log 5. Here we are going to, first we are going to apply the power rule, because each term begins with log, as you can see, log, but here it's 2 log 5. So in 2 log 5, if we apply the power rule, this becomes to log 5 power 2. Log 5 power 2. Second, we are going to change 2. We are going to change 2 into log form. Now changing 2 into log form, I think I have already shown you as 2 is be equivalent to log, or log base 10 is equivalent to 2. This will be log, because if 2 become the power 10, this becomes log 100 base 10. Therefore, we are going to solve this question as, we are going to solve this as log of 7x minus 3 to brackets plus 5 plus, sorry, this is log, this is plus log of 5 power 2. This will be is equivalent to log of 100 plus log of x plus 3 into brackets. Remember, the base 10 is not indicated, but wherever you see log not indicated, know that it is base 10. Now from this, since from this equation, this is equal sign here, from this equation, since addition goes with multiplication, we say that log of 7x minus 3 into brackets times 5 squared is equal to log of 100 times 3x, log of 100 times x plus 3. By dropping the logs on both sides, we say that this is 7x minus 3 times 25 is equal to, here we're going to multiply here. This will give us 100x plus 300, which this will give us, if we multiply this, will give us 175x minus 75 is equal to 100x plus 300. Note that the smaller coefficients will always follow the big coefficients in such equation. Therefore, 175x minus 100x is equal to 300 plus 75. This will give us 75x. 175x divided by, this is 75x, or divided by, not really, is equal to 375. Divide by 75 on both sides. Now see that if 75 goes, this will further give us, x will be by 75, 1 by 75, this is 5, because this is 5, therefore x is 5. X is 5, this is 5, and this is the answer. Now we can as well check the answer if we substitute x is 5 from the equation. If we substitute 5, because our x is 5 and this is the answer, if you substitute it from the main equation, you are going to prove that that is the correct answer. Note that for any logarithm question to be correctly set, the bases must be the same. As you can see, this is base 10. Now we are in question number 20. Question number 20 states that, okay, find the value of x given that log x minus 1 plus 2 is equal to log 3x plus 2 plus log 25. Okay, this was the KCC. Was KCC 2015 paper 2 number 7, given 3 marks for this question. Say that this question, first, the log in question is base 10, because log not indicate a second. From the equation 2 is not in log terms, we must change into log form since the coefficients are in log. Therefore, okay, this can be as well. Hence, therefore, we say here we're going to say that we are going to start with, this is not in log, therefore 2 is equivalent to, this is 2 is equivalent to log, this is in base 10, which is also the same as log base 10 is equal to 2. When 2 becomes the power 10, this will be log of 100 base 10. Therefore, the equation will be log of x minus 1 plus log of 100 is equal to log of 3x plus 2 log of 3x plus 2 plus log of 25 plus log of 25. Since we are adding two logs in both sides, of the equation, I mean these are two logs and these are two logs. This is equal sign. These are two logs and these are two logs. Now, since we are adding two logs on both sides of the equation, we are going to take one log as but we always remember that addition goes with multiplication and subtraction goes with division. Don't cross multiply equal sign. Don't cross multiply equal sign at this stage because x is in both sides. It's logarithm rules. Hence, we say log 100 multiplied by x minus 1 is equal to log 25 multiplied by 3x plus 2 plus 2. Now, by dropping the two logs in both sides and multiplying each independently, cross equal sign, say 100 times x minus 1 is equal to 25 times 3x plus 2. This will give us 100x minus 100 is the same as 75x plus 50. This will further give us 100x minus 75x is the same as 100 plus 50. This will give us 25x is equal to 150. Now, this will give us 25x is equal to 150. Dividing 25 in both sides, x will be 6. And I think this is the answer because we are finding the value of x now. X is 6. And that is how we can. Question number 20 is, remember to subscribe, click the small bell once, then share to your friends, not forgetting your enemies too. So question number We are now in question number 2. We are going to solve question number 2. Then we go to question number 8. So question number 2, this is how we are going to solve question number 2. Solve. The question says solve x in the equation 2 log x plus log 5 is equal to 1 plus 2 log 4. This is 4 marks. A KCSE question of the year 1993, paper 2, question number 4. Okay, for this question, say solution. Leaving, okay, question number 2, because we can see that it's 2 log, because both they should start with log here. We are going to apply the power rule in 2 log x base 10. If we apply the power rule, this becomes log of x base 10 x power 2. If we apply the power rule, hence this will be log of x power 2 base 10 plus log of 5 base 10 is equal to, we have already solved 1 is equivalent to log of 10 base 10, because our base is 10, because we have already solved the value of 1 several base. Then we say this is plus, because since 2 is 2 log 4, this way if we apply the power rule here, you say is equivalent to log of 4 power 2. Hence we say that, note that we apply the power rule in both sides. Hence this, please also note that the difference between question number 25, the difference between the unknown x in question number 25 and in question 2, hence their working are different, as we say that here we are going to say that if we reach this point, say since addition goes with multiplication, and subtraction goes with division, we say that our x, this is x, if this value crosses the equal sign, this will be log of x squared to base 10 is equivalent to log of 10 base 10 plus log of 4 squared log base 10 minus log of 5 base 10. And that is how it should be. Note that this is because x is unknown, hence we say that for this one we are going to say log of x squared base 10 is the same as, we are going to drop the logs here, and since addition goes with the multiplication and division goes with subtraction, we say that, sorry, this is 10, okay, we say log of 10 times 4 squared, all divided by 5, by dropping the logs in both sides. Both side, I mean this left hand side and the right hand side, we say x squared is the same as 10 times 16 over 5. Hence x squared is the same as 160 divided by 5. This will give us, if we need square, we have square root both sides. The x is the same as the square root of 32. The square root of 32, because by 1 by 5, this is approximately 32. And the square root of 32 is equivalent to, this will give us 5.6. And this is the answer for the question. For those who have got them at familiar, they are at liberty of checking the answer if they are correct. Okay, for question number 8. For question number 8 states that solve the equation log x plus 25 minus 2 log 3 minus log 9 minus 2x 3 max. This was a KCC 2001, paper 2, number 8. Okay, for question number 8, this is, say, solution first. First, you see how we are going to start here, negative 2 log 3. We take 2 alone, not considering the negative sign, because considering the laws of logarithms, subtraction goes with division. Hence, 2 will be the power in log 3 power 2. Not for the 2 to be power in 3 squared. Also enables every term in the equation to begin with log. Hence say that log of x plus 24 minus log 3 squared is equal to log of 9 minus 2x. This will be log of x plus 24 minus log 9 is the same as log of 9 minus 2x. By applying the laws of logarithm, subtraction goes with division and multiplication goes with addition. Since we are dividing, we are allowed to use one log on the left hand side of the equation. Therefore, log x plus 24 divided by 9 is the same as log of 9 minus 2x. By dropping the logs in both sides, x plus 24 over 9 is equal to 9 minus 2x. Okay, this will give us x plus 24 over 9 is equal to 9 minus 2x over 1. By cross multiplying, we say 81 minus 18x is equal to x plus 24. So 18x plus x is equal to 81 minus 24. If we add, we say 19x is equal to 81 minus 24, this gives us 57. Therefore, since we need x, we divide by 19 in both sides. X will be 3 times 19 is equivalent to by 19 1 by 19 3. Therefore, x is 3, and this is the answer. This is the answer. So for our learners, that is how these questions are calculated. So we are going to solve question number 14. We are going to solve question number 14. Question number 14 states solve for y in the equation log 3y plus 2 minus 1 is equal to log y minus 4 3 marks. This was KCC 2008, paper 2, number 12, question number 14. So for this question, we are going to solve for y. Solve for y. Here we say solution. This is log 3y plus 2. This is base 10 as indicated. Minus log 1 is equivalent to, we have seen that 1 is equivalent to log 10. 1 is equivalent to log 10 base 10. Hence, this will be equivalent to, this is equal to log y minus 4 all to base 10. Remember, we have 1 is equivalent to log 10 base 10. We have already shown our calculations in the previous questions. So for this, we say that we're going to say that log 3y plus 2 is equal to log y minus 4. Since both are base 10, here we are going to, this is over 10. This is over 10. By dropping the logs in both sides, we say that 3y plus 2 over 10 is equal to, because 10 over 10, because of we have dropped the logs and you see there is minus here. Addition goes with multiplication, but division goes with subtraction. That's why we have divided 3y plus 2. 3y plus 2 divided by 10 will be equal to y minus 4, because this y minus 4 over 1. Now, by cross multiplying the equation, when we cross multiply the equation, we get, here we're going to get 10y minus 40 is equal to 3y plus 2. Now 10y minus 3y is equal to 40 plus 2. 7y is equal to 42. Then if we divide both sides by 7, get y is the same as 6. And this is the answer. This is the answer for the question. Y is equal to 6. We are going to solve question number 3. Question number 3 states that find the value of x that satisfies the equation. 4 marks. This was KCC 1994. KCC for the year 1994. Paper 2, question number 14. Log of 2x minus 11 minus 2 minus log 2 is equal to log 3 minus log x. Okay, this is question number 3. If we have been instructed to find x, first we collect like terms together. Hence our solution is say collect like terms together. So this will give us log of 2x minus 11 minus 2 log minus log 2 is equals to log 3 minus log x. By collecting like terms here, say log 2x minus 11 plus log x is equal to log 3 plus log 2. Okay. Second, we are going to consider that addition goes with multiplication and subtraction goes with division. Therefore you say, want to say that log of 2x minus 11 times log x is equal to log 3 times log 2. Sorry, this is log 2. This is log 2. Third, we take single log from each side. Hence, this is log 2. By taking single log in both sides, we say log 2x minus 11 times x is equal to log 3 times 2. By dropping the logs in both sides, say 2x minus 11 times x is the same as 3 times 2. This will give us by multiplying here we get, we are going to 2x squared minus 11x minus 6 Now this can be written as, sorry, this is not, it's 2x squared minus 11 is equal to 6 from the equation here. Then this will give us 2x squared minus 11x minus 6 is equal to 0. By solving the quadratic equation, term C is 12x product. This is product sum. Sum is x, therefore 2x squared minus 12x plus x minus 6 is equal to 0. This will give us 2x plus 1, two brackets, x minus 6, two brackets, is equal to 0. This will give us 2x plus 1, 2x plus 1 is equal to 0, or x minus 6 is equal to 0. Now 2x plus 1 is equal to 0, or 2x is equals to negative 1. Now 2x is equal to negative 1. To get x, you have to divide both sides by 2. Hence x is negative 1 over 2. But we also know that the other side we get x minus 6 is equal to 0. Hence x is 6. Therefore x is negative a half, or 6, and this is the answer. That is the answer for question number 15. Question number 15. Question number 15 states that find the value of x given that log 15 minus 5x minus 1 is equal to log 3x minus 3. This is 3 marks. KCC 2010, paper 2, number 15. Okay, you say solution. Here we know that this can be written as log 15 minus 5x, log 15 minus 5x, this is 5x, minus log 10 base 10, because the bases, since 1 is the equivalent to log 10 base 10, as if we consider 1, not the negative. We take 1 in log, not the negative. We have already explained this in our previous questions, so I think this will be equal to log 3x minus 2. This is also base 10. This will give us for this case we are going to collect like terms here, as we have seen that log 15 minus 5x and log 3x minus 2. This will, if it crosses the equal sign, becomes minus log 3x minus 2. Hence, this is base 10. Base 10 is equivalent. This is negative. It crosses the equal sign, becomes positive. This is log 10 base 10. And by dropping the logs in both sides of the equation and considering that addition goes with multiplication and subtraction goes with division, we say this will be 15 minus 5x over divided by 3x minus 2 is equal to 10. By cross multiplying both sides, because this is divided by 1, by cross multiplying both sides we get 30x minus 20 is equal to 15 minus 5x. Now 30x minus 5x is equal to 15 plus 20. This will give us 25x is equal to 35. And if we are looking for x now, if we're looking for x, then say 25x is equal to 35. 25x is equal to 35. If we're looking for x, divide both sides by 25. This goes x is the equivalence of 35 divided by 25. This gives us 1.4 or 1 if we round off, and this is the answer for question number 15. Now we are in the last question. This is the last question, question number 12. Question number 12 states that without using mathematical tables or calculator, evaluate 6 log base 2 times root 64 plus 10 log base 3 times the fifth root of 243. Okay, for this case, we say solution. For this case, we say solution. First, for this case, we don't doubt or consider unlike bases since we are working on logs of roots. Second, for the case of cube root of 64, think of any number in which when you multiply itself 3 times, you get 64. Therefore, let us try the numbers. Let us try the numbers for the cube root of 64. Let us then try the numbers. Let's try number 1. Number 1. 1 times 1 times 1. This is 1. Now 2 times 2 times 2. This is 8. 3 times 3 times 3. This is 27. And 4 times 4 times 4. This is 4 times 4, 16 times 4 is 64. This is 64. Therefore, 4 will replace the root of 64. For this case, for the case of the fifth root of 243, for the case of the fifth root of 243. We still try numbers. We try number 1. Multiply itself 5 times. 1 times 1 times 1 times 1 times 1. 1, 2, 3, 4, 5. This is 1. 2. 2 times 2 times 2 times 2. 1, 2, 3, 4 times 2. This gives us, this is 32. And 3, this is 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. This gives us, this is 9, 9, 81. 81 times 3, this is approximately, this is 243. Therefore, 3 will replace the fifth root of 343. 3 will replace the fifth root of 343. Therefore, we say 6 log base 2 plus 10 log 3 base 3 sorry, this is 6 log 4. 6 log 4, because these two represent the roots. This is 6 log 4 base 2 plus log 10 plus log 10 plus 10 log 3. Now, since the bases are different, we find the logs of each logs independently first, then we multiply with the whole numbers. Therefore say that log 4 base 2, log 4 base 2 is 2, since 2 power 2 is 4. For this case, for the case of log 3, this is 2, and for this case of log 3 base 3, log 3 base 3 is 1, since 3 power 1 is 3. Since this is 1, since 3 power 1, 3 power 1 is 3. Now we say from our equation here, this is 6 log 4 plus 10 log 3. This is 2. By dropping the logs and following the laws of logarithm, if we drop the logs here, this will be 6 . This will be 6. Now we are going to consider the values we have gotten. We are going to use these values here. We are going to use these values. This will be, by dropping the logs, we say this will be multiplied by 2 plus 10. In 3 there is 1, we multiply by 1. If we bracket this becomes 12 plus 10 plus 10, 12 plus 10. sorry, because we have dropped the logs. Sorry, this is not plus, this is multiplication, because multiplication goes with addition, goes with multiplication. We are still considering the laws of logarithm, so this is multiplication. We are still considering the laws of logarithm here. So this is multiplication. 12 times 10 is 210, and this is the answer. Note that this question is similar to question number 5b in part 1 video of this topic. This question is similar to question number 5b in part 1 video of this topic. Thank you for your time. Have a good day.